All right, 29. Solve the system. If the system has indefinitely many solutions, write the solution set with x arbitrary. And we have three equations, three unknowns, x, y, z. Equation 1, 3x plus y plus z equals 4. Equation 2, x minus y plus 3z equals a negative 6. And equation 3, 3x plus y plus z equals 10. And what I like to do is, especially with three equations, three unknowns, is I like to label each of my original equations as 1, 2, and 3, just to help me kind of stay organized here. And notice right away what we're going to do is try to eliminate one of the variables, either x, y, or z. And you can start with eliminating any of the three variables. It's really up to you. But notice in our system, if we look at equation 1 and equation 2, notice how the y's are set up perfectly to eliminate. Here we have a positive y, here we have a negative y, so those are set up perfectly to eliminate. So let's go ahead and eliminate, using equation 1 and 2, the y. So if we have 3x plus y plus z equals 4, and x minus y plus 3z equals negative 6. Again, those y's perfectly cancel, so that's why we're going to go ahead and start with equations 1 and 2. So we have 3x plus x gives us 4x. The y's go away, and here we have z plus 3z gives us 4z, and 4 minus 6 gives us negative 2. And now that we've eliminated the y from equations 1 and 2, I'm going to go ahead and call this new equation equation 4. All right, and we'll come back to this new equation, equation 4, in just a second. And now what I want to do is I want to eliminate the y variable from, and again, because equation 2 and equation 3 are perfectly set up to eliminate y, let's go ahead and use equation 2 and equation 3. All right, so x minus y plus 3z equals negative 6. And now we're going to use for the first time equation 3. 3x plus y plus z equals 10. And let's go ahead and add 4, or rather x plus 3x gives us 4x. Negative y plus y goes away. And 3z plus z is 4z. Negative 6 plus 10 is positive 4. And now that we've eliminated the y variable from equations 2 and 3, let's go ahead and call this new equation equation 5. And notice with equation 4 and equation 5, we don't have a y in either of these two equations. So we can set up now another elimination and try to get rid of either the x or the z, and we'll go ahead and do that off to the right here. So 4x plus 4z equals negative 2, so this is equation 4. And then let's go ahead and write equation 5 underneath. All right, so there's equation 5. And again, we can choose to eliminate either the x or the z. It doesn't really matter. Let's try to get rid of the x. So if we have a positive 4x here and a positive 4x here, well, we can multiply, how about the top equation here, by negative 1. And what that'll do is give us negative 1 times 4x is negative 4x. Negative 1 times positive 4z is minus 4z. Negative 1 times negative 2 gives us negative 8. Or excuse me, gives us positive 8, doesn't it? So, oh, I'm looking at the wrong one. Negative 1 times negative 2 gives us positive 2. All right, there we go. And now let's go ahead and see what happens. So 4x minus 4x, well, that goes away. 4z minus 4z, that also goes away. So on the left-hand side, everything cancels, so we're left with 0. And then here on the right, we have 4 and 2. Well, 4 and 2 gives us 6. And so we're left with 0 equals 6, aren't we? And is this a true statement? Does 0 equal 6? No, that's not true. That's false. And so since we got a false statement as we were solving this system, this tells us that there is no solution to the system. There's nothing we can do. We can't move forward because when we tried to solve for z, remember we were trying to eliminate the x variable here, everything eliminated. The x and the z eliminated, and we ended up with a false statement. So we can't go any further. This system has no solution. So when you're solving, if you get a false statement, you know that your system has no solution. All right, let's take a look at number 30. I'll see you there.